Welcome, ladies and gentlemen. So what I like to do is show you how to simplify an expression using all of the rules of exponents. So I try to grab every single possible rule of exponents that I could that we've gone over and kind of bring them all together into some of these kind of big problems that look very confusing, but if we just kind of follow a step-by-step little process, they're really not as bad. And again, we're just going to be following the rules of exponents that we have been practicing throughout these videos. So the first thing that I always like to, whenever I see a negative, I usually typically like to get rid of the negative first. And if you notice here, I have the negative in the denominator, so therefore I understand I can rewrite this as a positive by bringing it up. Positive to the first power. And what's nice about bringing it to the positive first power is I realize, well, I don't really need to do anything. 4xy to the first power is just 4xy. However, I do see I have xy squared raised to the third power. Notice the 2x is not inside, so I'm not going to be raising that to the third power. But the xy squared is, so therefore by using the power to product rule, I need to rewrite this as 2x, x cubed, y squared, cubed, and then times 4xy, which I can simplify into 2x to the fourth, y to the sixth, times 4xy. And now just kind of moving my terms around, I can multiply 2 times 4, which is give me 8. X to the fourth times x is x to the fifth. Y to the sixth times y is y to the seventh. So therefore, that would be my simplified term. So you can just kind of see I got rid of the negatives, applied my power to product rule, and then kind of just combined my terms as needed. In this next example, you could get rid of the negative first, but I think what's kind of easiest in this one is whenever you have inside parentheses, and you always want to look to simplifying. Over here, there's really nothing I could do inside the parentheses to simplify. But using my order of operations, I want to see what I can simplify here first. And I realize I can actually use my quotient rule as well as use my quotient rule on the inside. So 3 over 15, that can be reduced to a fraction as 1 over 5. And then here I'd have a squared minus 7 and b to the fifth minus 3. Well, that's going to leave me with, let's just kind of go back and review, a to the negative fifth, and that's b to the squared. So therefore, that would leave me with b squared over 5a to the fifth. Because remember, whenever it's a negative, we need to make sure we put it in the denominator. And then again, this is still raised to that negative second power. Don't forget about that, all right? Now, remember what we talked about as far as the reciprocal. If you have a fraction raised to a negative power, you can just reciprocate that to put it as the positive. So therefore, I can rewrite this as 4a to the fifth over b squared over to the second power. And now I can use the power to product property as well as the power to quotient property to raise each and every term to that second power, since they're all separated by multiplication. And therefore, I have my final answer of 25a power rule. A to the fifth raised to the second is you multiply them, so that's going to be a to the 10th over b squared. And that would be my simplified answer. Over in this next one, again, you can see we have some negative powers. So first thing I would want to do is just rewrite those as positive powers. So I have 3x squared times xy again to the first. And then this is now going to go in the denominator, which is 2xy to the fourth. Now, for each one of these power to products, I'm going to simplify that. So again, remember the power to product rule basically means you're going to distribute that to each term. So that's going to be 3 squared times x squared squared, and then just multiply by xy, over, notice how the 2 is inside the parentheses here, where here the 2 was not outside the parentheses. So I need to raise 2 to the fourth power, and then x to the fourth power, and y to the fourth power. Simplifying that, I get 9x to the fourth times x times y. All over 4 to the fourth power is going to be 16, x to the fourth, y to the fourth. Notice here how I could use my quotient rule, but just notice how x to the fourth divided by x to the fourth is obviously just going to divide to 1. 9 over 16 cannot be simplified, so you're going to leave it as that. And then here I could divide, I could use the quotient rule. 1 minus 4 is going to be a negative 3, so we're going down. Or you could just kind of divide those out and say that's going to be equal to a 3. So my final answer is 9x 9x over 16y cubed. Okay? All right, last but not least is, again, another problem where we have a power on the outside and we have a whole bunch of stuff going on the inside. So again, what I would do is simplify the inside, and the first thing I'd like to do is get rid of the negatives. So I'm just going to rewrite everything with positive powers. So I'd write that as 3. I'm going to bring that down and then bring this up. Notice how a squared is not raised to the negative, so that's going to stay in the denominator. So it's going to be 3 times ab times to the first power over a squared times a squared b raised to the third power. Again, this is all raised to the second power. So just notice how I just swapped these to put them in the numerator and denominator, but to then make them positive. Now I can go ahead and simplify. The numerator is pretty simple. That's just going to be 3ab. Denominator is going to be a squared, and that's going to be a. I'm going to do this kind of quicker, so I'll do a squared times 3, which would be a to the, multiply them, is going to be a to the 6th, and b is going to be b cubed. Okay, and now I can simplify this a little bit further. 3a, simplify my numerator or my denominator, which would give me a to the 8th, b cubed. And therefore now I can kind of divide out a term. So therefore my final answer is 3 over a to the 7th, b to the 2nd. So there you go, ladies and gentlemen. That is how you use all the rules of exponents to simplify rational expressions. Thanks.